Welcome to 3.5. We're going to be talking about surface area.
Bow, bow, bow.
And surface area, when we're talking about that, it's the combined area of every exposed surface of a figure. So when you're given a figure, it's got all its various faces, and we're taking the area of each of those faces and adding them together. This is for things like if you had to paint something, how much paint would it take? Like how many square centimeters or square feet would be required for that? Or if you have to cover it in wrapping paper, for example, if you gave someone a gift, how much wrapping paper at the bare minimum would you need? So this is what this kind of ties to.
So when we're talking about surface area, you could actually take a look at your formula sheet that you got at the beginning of the year, and you will see this section. And this section has two pieces to it. The first one is 2D shapes, and these are the formulas that you should probably be pretty familiar with. They are for square, circle, rectangle, triangle. This top row here talks about perimeter. Of course, when we're talking about circles, we often say that perimeter is its circumference, but it kind of refers to, again, that edge piece around that shape. This second row refers to its area. So how do I find an area of a 2D shape? And then the third row is, of course, just a pictorial view of those shapes. What we're going to be more focused on in terms of grade 10 concepts are 3D figures. Now, when we are figuring out the surface area of a 3D figure, we actually have these super handy dandy equations, and the fact that we're talking about surface area, we're going to be only talking about these three. So 1, 2, 3. We will get to the ones for volume later on, and those are the ones found in the row below. But taking a look at these, they're general formulas. So if I'm talking about a prism, that could be a rectangular prism, a triangular prism, anything that has two bases that are identical and that are connected. And so a cylinder would also be considered a prism. It's just circular prism sounds kind of funky, so cylinder it is. And what this formula says is 2 times B. B represents the area of the base, right? So depending on what shape you have as the base, the area will be different. And those areas are based on, those 2D shapes or a combination of those 2D shapes as before. So we have the 2B, two bases for a prism. That kind of makes sense. That capital P stands for perimeter of my base. P equals perimeter of the base. And again, those perimeters of the bases, you'll use those 2D shape perimeters / circumference to be able to figure out the value for that capital P. And again, it'll be different based on the prism or cylinder that we have in play. H just refers to the height, so nothing too crazy there. When we are talking about regular-based pyramids or cones, particularly square-based pyramids and cones, we are going to be looking at this formula here. And we still have that B, that capital B. That capital B still represents the area of the base. And that capital P still represents the perimeter of the base. And now we have introduced a new variable. This S represents the slant height. The difference between height and slant height is one is on a tilt. Height is actually vertical, straight up and down, where slant height is not quite straight up and down, but from the apex or the vertex of your shape down towards the base edge.
Yeah, and we'll see examples of that as we draw some of these figures so you know exactly where to place that.
Last but not least, this formula we have sphere, and as you might have guessed, R stands for radius. But these are the 4 variables that we will be kind of introducing in surface area when we look at our shapes that you should be familiar with.
So as I said, we're going to tackle some examples, but as we get into ones that have straight on numbers in them, we're going to take these kind of general formulas that we have and then apply them to slightly more specific figures. So rather than just any prism or any cylinder, like what if we, as Ms. Tibbs said, what if we had a square base prism or a rectangular base or triangular base prism, and same thing for pyramids. So here we go. We're going to sketch a square-based pyramid. We're going to get a formula for the surface area of a square-based pyramid in particular, based on its base side length and slant height. So drawing-wise, if this thing has a square base, we'll draw it all kind of perspective-y. And there it is. And from that one point, I'm just going to connect these sides. So close. So there is a square-based pyramid, and the side lengths of it are what we can label as B. And this slant is what connects the top, that very peak, to this base at a 90-degree angle. So you can draw it there, you can draw it here, and there it is. So this is S. According to what we had on that formula sheet, the surface area of this is equal to the area of the base plus half times the perimeter times the slant height. And if we apply that to a figure like this, we could say that the area of the base is just a square here. So it's just B squared. And the perimeter, in this case is the perimeter of a square. So we've got B plus B plus B plus B. So the perimeter is 4B. And if we plug those into that formula we have up top, then we can say that the surface area, instead of B, we can say that's little b squared, coming from this, plus half 4b times s. And that's replacing that perimeter. From here, if we were to simplify, we could say surface area is b squared plus 2bs. We don't have to memorize that because we're not given it, but as long as we know where it kind of comes from, we can always piece things together.
That is such a good point. So we're going to be given those general formulas. We can figure out the specifics as we need them. So next we have a rectangular prism, and we want to figure out a general formula based on its length, width, and height. So here we have a rectangular prism, and by here I mean I'm about to draw it. And rectangular prism. And I'm not good at drawing identical things, so one at the top, one at the bottom. Scoot it out for just a smidgen, and then I'm just going to connect corner to corner. I understand that I did not do as good of a job making my lines dashed or dotted as Mr. A did, but luckily I can pretend I did this whole time. All right, so here we have a rectangular prism, and because it is in fact a prism, our general formula for surface area is 2 times the area of the base plus my perimeter of my base times height. And for a rectangular prism, it doesn't matter what side's actually considered the base, because realistically, the base is anything that is identical at the top and the bottom, and these two are identical if I put those down on one side. What else? These two are identical if I have it currently standing in the way it is. And these front and back ones are identical if I wanted to flip it over on its other side there. So the actual base doesn't matter as much when we're talking about a rectangular based prism. But when we have something like a triangular based, the base does in fact matter. The base is going to be the shape that's specified in the name, something to just kind of keep in mind that people mix up down the road. So here we go. When we are taking a look at what my area of the base is, well, looking at my shape, I know that I will have length, I will have width, and this dimension here would be height. So if I'm looking for area of the base, that's the area of this rectangle down here, and I can figure that out by saying length times width. For my perimeter of, again, that same rectangle, I can find my perimeter by saying, well, 2 times length, because I have one here and one here, plus 2 times W, because one here and one here, will give me the perimeter. Now that I have those values for my area of the base and perimeter of the base, I could plug those back into my original formula. So my surface area for a rectangular prism would be 2 times length times width, because again, length times width is the same as the area of the base, plus my perimeter, which is 2L plus 2W, which again is same as my perimeter of the base, times by my height. Notice that when I plugged this in, I had to put brackets around it, because if I didn't, I wouldn't actually be the same thing as multiply that perimeter by my height. I want to multiply the perimeter as a whole by my height. So I need to make sure that is in brackets. If I did not have those, I would only be technically multiplying part of my perimeter by the height. So the brackets there are important. So we can distribute this h to both of the terms inside my brackets there to give me my surface area as 2 length times width. Length times width. And then if I distributed that h, I could have 2 length times height plus 2 width times height. And there we have it.
We're going to get the general formula for a cylinder, so that circular prism that we talked about. We're going to get that. So drawing this out, ooh, there's the top, ooh, and there's the bottom. It's got a height, and it's also got a radius, R for radius. And we'll get a general formula for its surface area. Now, as we've always stated, surface area is 2b plus ph. You might eventually memorize that for how frequently we use it. In any case, for the base, that's the circular base. So then that has an area of pi r squared. For the perimeter, again, that base is circular. So when we talk about the perimeter, we're talking about the circumference of a circle, which is 2 pi r. Putting those into this formula, 2 times the base, which is pi r squared, and we're adding our perimeter times the height. And right there is a formula for the surface area of a cylinder.
All right, now we're going to do a cone and look at the general formula, or use the general formula to figure out a specific formula. So we have our cone, and we know that in a cone we have the radius here and the slant height, which goes all the way from the peak to the edge of my side length there. So this would be labeled S. When I'm taking a look at my general formula for surface area, I know that there's just one base, and I'm adding half of my perimeter of the base times my slant height. I prefer to write it as perimeter of the base times slant height divided by 2 because that's the same thing. So just in case you see it in an answer key a little bit differently, know that that is identical. When I am looking for the area of my base is a circle, so I would have pi r squared. If I am looking for the perimeter, my perimeter of my base, that would be the identical of my circumference, which I could say is 2 pi r. I could also say pi times diameter, but why introduce a third variable when I could base everything off r here? And that's really all I need to do other than put it all together. So here, instead of capital B, or area of the base, I'm going to put pi r squared. Instead of capital P, I'm going to put 2 pi r. And I still have times by s over 2. And so just to kind of recap here, this pi r squared came from this value of b. This 2 pi r came from this value of p. As I notice, I'm looking at this here, I notice that this final term could be simplified because it's being multiplied by 2 as well as divided by 2. So I could go ahead and simplify that and say my surface area is equal to pi r squared, that's still the same, plus pi r s, because a 2 at the top cancels out with the 2 on the bottom.
There is a little bit of a summary of some of these down here. Now these, again, won't be provided to you. The only ones provided to you are the ones on the formula sheet. But these are some that can get developed by developing it as we did these ones just now.
Yes, so when you're doing the practice, it is our recommendation that you practice using the formulas on the formula sheet, just so that you are able to derive them yourselves. But if you wanted to practice deriving them and wanted to see where you'd end up, these are provided to you.
Yeah, if you want to use those other ones, you'll have to memorize them. Hey, poops, let's get to even more specific figures. So not just a general height and radius, but specifically a given height and radius for a cylinder. So we're going to sketch it, we're going to determine its surface area, and we're going to provide the exact value as well as the approximate numerical value to one decimal place, and that's only if they differ, because they might. And where that's going to happen is in cases where pi is involved, or maybe square roots, possibly. But for now, probably just the business of pi. For example, for a cylinder, with a radius of 2 and a height of 3, we can find its surface area. Surface area is 2b plus ph, where b, the base, is pi r squared, and p, the perimeter or circumference in this case, is 2 pi r. So that's same as what we had above. But now we can substitute in values we know, like r is 2, and h is 3. When we simplify an expression like this, it's kind of just like simplifying something like 2x times 2 squared plus 2x times 2 times 3. So pi it's a letter. It's a Greek letter, but it's a letter nonetheless, and you can kind of treat it operationally just like you would a variable. So with that in mind, we have 2 times pi times 2 squared. So that's 2 times pi times 4, which is 8 pi. And then 2 times 2 times 3 is 12. And that's being multiplied by pi as well. And just as you would collect terms if you had 8x plus 12x to give you 20x, we can do same here and say that this is 20 pi. We had 8 pi's, we had another 12 pi's, that's 20 pi's in total. And then of course, noting that these were in centimeters, we're going to use centimeters as the basis here, but surface area is a two-dimensional measure, so centimeters squared. That is the exact value. To approximate it, I would need to punch that into my calculator. I would actually type in 20 times pi.
Note that when you're plugging it into your calculator should have the pi button. So you should not be writing 20 times 3.14, because that will give you a rounded answer and potentially introduce an E6 rounding error. So make sure you're using the pi button. If you can't find that, we're more than happy to help you with that next class.
Yeah. And as we multiply this, when we round to the nearest tenth, we get 62.8 centimeters squared. So this is the approximate value. And it's worth doing a quick check here to make sure if that makes sense. 20 pi is a little more than 20 times 3. Since pi is a little more than 3, this is a little more than 20 times 3, so we might be okay.
All right, taking a look at this next one here, we have a cone. And so with our cone here, I'm going to draw it out. I know that my radius is 6 feet, and my slant height is 20 feet. I'm trying to find the surface area, and I know my surface area is the area of one base plus my perimeter of the base times slant height over 2. Right, so as I'm plugging that in, I know my area of my base is a circle, so I'm going to use pi r squared. I know that my perimeter of my base, which is still a circle, my perimeter is 2 pi r times s, and I still have over 2. Right, this was one of the formulas that we did on the previous page together, and we noticed that in that second term, our 2's canceled out at the top and the bottom, leaving us just with pi r s. Now we can plug in our values for r and s into this equation because we are ready to go. Instead of r, I'm going to write 6, so I have pi times 6 squared. And in the second term, I have pi times my radius, which is 6, times my slant height, which is 20. And here we can say, well, 6 squared is 36, so I have 36 pi. And in my second term, 6 times 20 will give me 120, so I will have 120 pi. And just like Mr. A said, we could treat those pi's almost like a variable in terms of how we collect them. So if I have 36 pi and I have 120 pi total, I have 156 pi. Now, of course, we are asked here for both the exact surface area as well as the approximate surface area. This here would be exact, but it would not give me full marks until I have the units. So if I have feet as my units at hand here, because again, area is a two-dimensional aspect, then I have feet squared. That is my exact value. If I wanted my approximate value, that little squiggle sign or squiggle equal sign means it approximates it. And I'm going to go 156 times that pi button in my calculator and rounding to the nearest, one decimal place? Yeah. We end up with 490.1 square feet.
Our next one, is a square-based pyramid. So I can draw this out with my skills. That, maybe some dottly lines. Nailing it. Pow, 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 and da-da-dow. Where this thing has a base of 8 inches and a slant of 10. So this is 10 inches right there. For a pyramid in general, surface area is the area of the base plus half PS, which in this case, that area of the base is, how you say, the base length squared, plus half, the perimeter is 4/8, and the slant is 10. Whoop, I guess we can have just plug that right in. Okay, so 8 squared plus half, 4 times 8 times 10. And then we can start evaluating things. We could probably just jump straight to our calculator at this point if we really wanted to. But if you feel like taking it in steps, that's cool too. 4 times 8 is like 32, times 10 is 320. And half of 320 is 160. And 160 plus 64 is 224 units. This was in inches, so our surface area is in square inches. We don't have to worry about exact versus approximate in this one because there's nothing to approximate in that particular case.
Lastly of these a couple examples here. We have a sphere. That's perfect, right? Right.
Wow.
And
I can't believe you drew that freehand. That's impressive.
thank you. I've been practicing. Oh, not that great. But here I have a sphere. And my sphere has a radius of 3 meters. Oh, I guess I could just label that R. I realize that's what we've been doing now. I'm going to label it R. Notice that in our general formulas, we have a formula specifically just for a sphere because we don't have any other shape that is exactly like it or similar in this sense. So I have my surface area, and I'm going to straight up use the formula given to me on my formula sheet is 4 pi r squared. All I'm going to do at this point is plug in my value for r. So, hey-o, sphere life is good life. So I have 4 pi times 3 squared, which means I have 4 pi times 9, which means I have 36 pi. If I want to talk about exact values, I need to make sure that I include my units. Because I have my units here in meters, my area units would be meters squared. This here is, of course, my exact value. But if I did want an approximate value, I would plug that in, 36 times pi, to the nearest tenth or 1 decimal place would be 113.1 meters squared.
Okay, we are going to determine the missing measurement for a few figures. So we took some where we had the measurements, we knew lengths and widths or heights or radii, and then we found surface area from those. Now we are given surface area and maybe some other dimension, and we are tasked with finding out what's missing. And we can still use a very formulaic approach for these. We've got a square-based pyramid with surface area 104 and base side length 8 centimeters. We're not asked to draw this in this case. If you want to, you can. That is certainly an option. And sometimes I do anyways, just because it might help me parse the information I've gotten. So I've got my square-based pyramid.
Woo.
It's got a base side length of 8 centimeters. So here's 8 centimeters as part of its square base. What we need for the surface area of a pyramid of any sort, we need to be able to get the area of the base, and then the rest of it is half the perimeter times the slant height. And we can get some of those. We can get the base no problem because we have the dimensions of that base. We can get the perimeter. That's all hunky-dory because, again, we have everything about that base. Whoa. But we don't have the slant. And that is what's missing here. So when we fill in everything we know, we can say that we know that the surface area is 104. The base we know as being 8 times 8. Half is still a half. The perimeter is 4 eighths. 8, 8, 8, and 8. So it's perimeter of a square. And the slant, I don't have a hot clue. So from here, we're just using our algebraic skills to isolate S. We can do a little bit of simplification of each of these terms. So 8 times 8 is 64. Half times 4 times 8 is 16. That's where we at. And then we're just being told that, so we subtract 64 from both sides. You don't have to show this subtraction. There's that. And you don't have to show that you're dividing, but you do have to actually perform that operation. And as we solve that, we get a value of 2.5. My writing just got smaller and smaller with each step.
Yep.
Anyways, looking at this, we are pretty much done except for the communication error that I would have gotten.
Check out that E5 though.
Yeah, them units. This is in terms of centimeters, so let's just make sure we throw in those centimeters. And then this one is Dawn.
A common mistake that people make is whenever they see surface area, they get in the mind, well, all of my units have to be squared. Don't forget. Haha, joke's on you. Slant height is a length. It is not an area, so it is not a two-dimensional measurement, so it does not require a two-dimensional unit.
Yeah.
Okay, let's take a look at the next one. Here we have a cone, and this cone has a surface area of 39 pi square inches and a radius of 3 inches. Notice that 39 pi here is an exact value. So yes, it's not a nice number in terms of like, oh, it's 17. Cool. But it's still a nice number because you still have pi involved. You're not given this decimal form. Ugh, decimals.
Yeah. Do you think 17 is a nice number?
I don't know. It's the first one that came to mind. Anywho, so here we have our cone. I know that my surface area is 39 pi square inches, and I know that my radius is 3 inches. Well, to find the surface area of the cone, I would normally have surface area is equal to the area of my base plus the perimeter of my base times the slant height over 2. Now, I can go ahead and find my base. I know my base is a circle, so I'm going to use pi r squared. I have my r. Ooh, baby. We good. My perimeter of my base, again, my base is a circle. 2 pi r. I have my r. Ooh, baby. We good. But this s here. Oy.
Come on.
We don't have that slant height, so we will need to figure out what that value of s is, and that will be our missing measurement in this case. So what I'm going to do is, similar to what Mr. Athai did, is start plugging in these values. So instead of surface area, I'm going to plug in 39 pi. Now, for my area of the base, I know that's pi r squared, so pi stays as pi. Radius is 3, so I have pi times 3 squared. For my perimeter of my base, my capital P, I have 2 times pi times r, and my r is 3. And of course, I still have my s for my slant height that I'm trying to find, and I still have that divided by 2. Now, what I'm going to do is go through each of these terms and simplify them a little bit. So I still have 39 pi over here. Nothing's really changed. Now, 3 squared is 9. I can write pi 9, but gross.
That's weird.
Just kind of like when you were writing a coefficient of x or a value multiplied by x, you're not saying, well, I have x3. You say, well, I have 3x. It's just a way that we have kept our work similar across the world. Mathematicians kind of all agreed, saying, this is the way ye shall be done.
This is the way.
So we will have 9 pi. And then here we have 2 times 3 divided by 2, so that just leaves us with 3. Of course, still having that pi and still being multiplied by s. Now, we would carry out this operation in the exact same way as if we had the pi's replaced by a variable. We would want to make sure that we're still trying to isolate our unknown, our s here. So what we're going to do is we're going to take this 9 pi and we're going to move it to the other side. Well, how do we move it? Well, we're going to subtract it. And if we do it from this side, we have to subtract it from the other. And as we do that, we should end up with 30 pi on my left-hand side here. And that's going to equal 3 pi times s on the right-hand side. And again, because I want to get s alone, right now it's being multiplied by 3 pi. To undo multiplication, I am dividing it, and I can't just do it to one side because dem's the rules. And when I divide, notice that my 30 over 3 reduces to 10. My pi over pi just straight up gets rid of those pi's. It reduces to 1 over 1, which does not need to be written down there. And on my right-hand side, I have s. Now, you could have written it the other way, so you could have written s is equal to 10, and I'm going to do that on the next line just because I didn't leave enough room for my units there. And I know that slant height has the same units as my radius, and that is going to be inches. Not inches squared, just inches.
Neat. One last example here, and you can feel free to try it on your own with your skills. And then check what we do. you're done. I'm going to draw out the cylinder. Cylinders are great. Nice little can of soup. Yeah, this thing has a radius of 6 meters. 6 meters? That's a huge can of soup. I hope it's chicken noodle.
Really? That's your go-to soup?
To an extent, yeah, like Mr. Noodles.
I guess for soup that comes in cans. Oh.
Yeah, okay, yeah, my Mr. Noodles comes in a package.
Oh.
But
Interesting.
Mr. Noodles, it's like ramen, man. Anyways, my surface area is 252 pi, which is a lot of pi. And 2b, b is my base. Base is a circle, so that's pi times r squared. Perimeter of this circle is a circumference, which is 2 pi r. And we still have h. That's our unknown here. So many questions surrounding what h could be. And then we'll just isolate it. Okay. Let's take that step of just kind of simplifying what we're working with. 2 times pi times 6 squared. Well, 6 squared is 36. 36, yeah, I was right the first time. Times 2 is 72. So we have 72 pi there. And then 2 times 6 is 12. So we have 12 pi h there. And then this is our variable to isolate. So let's take this thing and knock it over to that side. I'll subtract. This is working for me? Super duper. Oh gosh. 72 pi. Which means that I've got something like 180 pi over here. And that's equal to 12 pi h over there. Divide those, the pi's will cancel, and I'm just left with 180 over 12, which means that h is like 15. You are allowed to use your calculator for this, so you don't have to process that mentally. If you can, wicked cool. If you can't, that's okay. You still rock. Anyways, I've got my m in there for meters, my linear meters, because height is not a two-dimensional dimension. So height's 50 meters, and this thing is, I used orange.
The orange is nice. I agree.
It's a nice orange.
So there is
practice?
some textbook practice at the bottom.
Where?
Oh, literally right there. Oh, there it is. And other than that, I hope you give that a go. I hope it makes you just as happy as the smiley face did. And otherwise, if you have any questions, comments, concerns, you know where to find us.
On the line?
Or in person.
Ah!
All right, now that they know, bye!
Bye!